Hi everyone, I'm Emmanuel, this is Vlad, and we're both grad students working with Todd Murphy. In this video we will try to show you how to build a simple circuit that will allow you to see the phenomenon of diffusion in electrical systems.
So, you saw in your notes, there's something like this circuit right here, where you have the center capacitor is fully charged, the red one, and all the other ones are discharged. And over time, the charge moves from the center capacitor to the side capacitors, just like in the diffusion of ink. So to make a little graph of what's happening here, we look at the voltage at each node, and the voltage at this first node is going to be high initially, so at t is equal to 0. And the voltage of all the other nodes is going to be 0. And you can think of this as looking at it as a curve kind of like this. If we were to plot voltages between the nodes, if those voltages actually existed. Now, after a time, Ts, let's call it, which is, let's say it's a time constant, the voltage in the middle one is going to go down. And the voltages of the other nodes are going to go up as the charge disperses across the circuit. So the curve would look more like this. It'd be a much flatter Gaussian. And if we wait long enough, so if t is infinity, we're going to get that all the voltages are equal in all the nodes. So a horizontal line. Of course, we can't really build exactly this circuit, because this is an ideal circuit. But in this case, we're going to build something very similar to it. And for that, we're going to use a breadboard, which is a very easy way of building electrical circuits. And we're using components. You just stick them in the breadboard, and it works just fine. Emmanuel is going to tell you about that right now.
Yeah. So breadboards are pretty easy to use, actually. Most of them consist of 4 parts. You have one part right here, the second part, the third part, and the fourth part. The lower part and the upper part, they have holes that are connected in rows. So all the holes in this row over here have the same potential. The same goes for this row over here, this row, and the upper row. The 2 parts in the middle have holes that are connected in columns. So each column consists of 5 holes. So all these holes over here have the same potential, and the same goes for this column and all the other columns. The first thing we are going to do is we are going to connect the lower part of the breadboard and the upper part. For this, we are going to use a jumper wire. You stick it right here and right here. So you have the upper rail of the breadboard, and here is the lower rail of the breadboard. And what we just did is this. We connected this with a jumper wire.
All right. So now what we're going to do is we're going to add this middle capacitor, which in the nodes, it's the same as the other capacitors. But what we're going to do in order to make the circuit work better is we're going to use a big, beefy capacitor. It's about a 5 microfarad capacitor, which is really big. You would find this in, let's say, a power supplies for a computer, for a toaster, anything. You would have something like this. So what we're going to do is just connect it with the negative end. So if you look at the 2 wires, one wire is longer than the other. And it also says on the side, big minus sign. We're going to connect the negative end into the rail. And we're going to connect the positive end into one of the small connectors on the breadboard. Right, just like Emmanuel drew right there.
We move on then by taking a 330 ohm resistor and plugging it in right next to this capacitor. One lead of the resistor should be in the same column as the longer lead of the capacitor. And the other one, we just plug it in a random column of the breadboard.
And now I'm going to do the same thing, except on the other side. So another resistor, except on the other side of the capacitor. Next, we're going to add smaller capacitors, basically the other two capacitors on the sides. And again, we're going to put the shorter lead to the rail, and the longer lead, we're going to connect it to the other end of the resistor, just like this. And on the other side,
Okay, so far we have a capacitor that is basically connected in parallel with two RC circuits. If we were to charge this capacitor and then put it back on the breadboard, the electrical diffusion will still be there, but we wouldn't be able to see what's happening. If we are clever about it, we can visualize this process by using LEDs. An LED, you can think of it as a light bulb actually. If you apply proper voltage to it, it turns on. And this will allow us to visualize the electrical diffusion process. As you may notice, the LED has one lead is shorter than the other, and you basically follow the same rule as with a capacitor. The longer lead should always connect to the most positive potential. We'll go ahead and connect the longer lead to the same column as one of the resistors and one of the capacitors. And we do the same for the other capacitor as well. For the other resistor as well, I'm sorry.
just one thing, whenever you use an LED, LEDs have very low resistance and they tend to blow if you don't put a resistor in parallel with them. So what we're going to do is we're going to put a 1K resistor in parallel with the LED, just like Manuel is drawing on the board. Now, what we have here is a basic circuit that shows one stage, only two of the nodes in this figure, of electrical diffusion. And what we should do is make sure that it works before we proceed any further. Because if this doesn't work, the bigger circuit won't work. What we're going to do first is we need to charge this main capacitor. Right now it's empty. We're going to take it out. And we're going to apply the positive lead to the positive lead of a 9-volt battery and negative lead to negative lead of a 9-volt battery. And hold it there for like a second. So now this capacitor should be charged. And we're going to stick it right back to where it was. Make sure I'm getting it. And we see that the LEDs light up as the charge has moved from the center capacitor to the side capacitors. Now, maybe yours doesn't light up. Don't be alarmed. There are a couple of really simple things to check. First, make sure that all the positive and negative leads are in the correct place. So remember, the negative lead is the short lead, the positive lead is the long lead, and the negative lead always going to get connected to the rails. The other thing that could happen is one of the wires might have come unstuck on the breadboard. So make sure that all the wires are all the way into the breadboard. And finally, make sure that all the connections are where you think they are.
So you probably noticed that this circuit is symmetric, so we can very easily expand it in both directions by just following the same process as we did till now. So this is what we're going to do now.
Okay, the circuit is done. We're ready to test it. Want to see it in action? We're going to take the capacitor out and charge it again. Remember, the long positive lead of the capacitor goes to the positive lead of the battery. Touch it just for a few seconds. And now, there you have it, electrical diffusion.